welcome. This is Mr. TG. This is the second video on lesson 4 or 5. This lesson is going to show and demonstrate to you how to solve quadratic equations by factoring. Starting with the first one here. Number 1, as you can see, it's a quadratic equation which has potentially up to 2 answers. The first step, if you want to solve by factoring, is to set the equation equal to 0. So if we do that successfully, it's going to look like this: x squared plus 13x plus 36 equals to 0. Now you could replace that 0 with a y and do it on your graphing calculator, but I think you'll find factoring is much more efficient. And what we're going to do is we're going to take this trinomial and factor it into 2 binomials like we did in the previous lesson. That would be then x here, and I'm going to use plus 4 and plus 9. And the reason I'm using 4 and 9 is because 4 times 9 is 36, and 4 plus 9 is 13. The last step of solving this is to use what we call the zero product property. This states that if I multiply 2 numbers together, a and b in this case, and if the answer is 0, the product is 0, then either a is 0 or b is 0. So in this setting, we're thinking of this as my a term, and this is my b term. In order for this a term to be 0, x would have to be negative 4. You could also set x plus 4 equal to 0 and solve it. That's what you would get. I know if I place negative 4 in for x, that's going to turn that into a 0. And then to do the same for the b term, you would end up with x equals a negative 9. These are the 2 crossing points of my parabola. So if you would want to check this on your calculator and put y in, you'd find that your parabola does cross at negative 4 and negative 9. Now problem number 2 is a little bit different because it's not a trinomial, but we can still factor it. As you can see, it's the difference of squares. There are 2 perfect squares being subtracted. Anytime you have that setting, you can go ahead and break it down into 2 binomials, just like we did in the last lesson. X minus 3x plus 3 would be your binomial factors. We're going to be calling these conjugates later in the course. But basically, we know that the O and I will cancel out. That's why we don't have a trinomial up here. Again, zero product property is used, so we circle x minus 3 and x plus 3. You can actually, again, I didn't show this in the first step. If you have to, just set x minus 3 equal to 0 and solve for x, and you'll get your 3. And then do the same thing here. If you want to do this, you can. In fact, you have to do this with some problems. I'll demonstrate that. This is negative 3. So there are your 2 crossing points of that parabola. And you've just successfully solved the quadratic function. Obviously, 1 and 2, the way we've demonstrated this, it's much more efficient than programming it into your calculator. Now we have 1 left to do. What I would like you to do is factor number 3 into 2 binomials. It's a little tougher because we've got an a term that's 3. So I'm going to hit pause here and let you see if you can come up with the correct binomial factors. When you come back, we'll have it completed and I'll show you how to find the zeros. Welcome back. As you can see in front of you, I've successfully factored the 2 binomials. At least I think I have. Let's check it using FOIL. 3x times x is 3x squared. 2 times negative 1 is negative 2. 2 times x is 2x plus a negative 3x is a negative 1x. So I know I've got the correct factors. So again, applying the zero product property, we're basically, what we're going to do here is set each factor equal to 0. 3x plus 2, that's got to be equal to 0, or x minus 1 has to be equal to 0. Well, obviously this one here, x minus 1 is equal to 0, is going to give you a positive 1. There's one of your zeros. That's an easy one to obtain. This one's a little more challenging, so you may want to use the option of setting it equal to 0 and solving it like an equation. So we subtract 2, so we get 3x equals a negative 2, divide by 3, so x equals negative 2/3. There is, or negative 0.6 repeating. That would be your second 0 of this quadratic equation. So again, if you graph this on a graphing calculator, these 2 points would be your crossing points of your parabola.